In this video, we develop a simple performance interface and think about gesture as a compositional concept. In the My First Patch patch, we started with a single user interface object, the button object. As we developed the patch by adding a metro, we used number boxes as an additional user interface to control the arpeggio rate and perhaps modify the bass frequency and frequency intervals. In a well-organized patch, we would include comments to help the user understand the patch and to remind us of what we have done. There are many user interface objects in Macs. We could replace the number boxes in the My First Patch with sliders. Check out Macs Tutorial 7 on numerical user interfaces for more ideas. Sliders are great, but they're not very expressive. You might remember Schaeffer's law of permanence and variation that we discussed in last week's lecture. He suggested that in most musical systems, we keep one aspect of the sound constant while varying another aspect, such as pitch. Well, it turns out that in most practical musical devices, we are varying more than one dimension of the sound at a time. Often, pitch and loudness are being varied as we create each note. We're going to make a system that enables us to vary two dimensions or parameters of the sound simultaneously. To do this, we'll use an object called Picked Slider. Open the Picked Slider help patch to learn more about this object. As you can see, the left and right outlets produce a range of values from 0 to 127. We could use movement in the horizontal axis to change the volume and the vertical axis to change the frequency. Let's make a plan for what we need. We need something to make a tone. We've successfully used the cycle object, so let's continue with that. We need something to change the volume. Let's search for volume. Live.gain looks likely. Click to see the help patch. I can see that the terms volume and gain are related. I'll just try searching for the word gain. There is a gain object. Let's look at that. Okay, the help patch has some jargon in it about scaling, but the patch looks like the kind of thing we need, with a cycle object feeding a gain control. I can see that the gain control accepts a range of values from 0 to 127. This matches the range of the picked slider. We'll learn later that this is related to the underlying design of the MIDI musical instrument digital interface. Let's patch it up. Pause the video and have a go at creating the patch. Okay, here we go. I'll use the horizontal axis to control the gain object and connect the output of the cycle object to the gain. Now we need an audio output. We know the DAC object works for this. Hooray, I have a volume control. But what about the frequency? Now we could just try patching and see what happens. Often this is the best way to go. Or we could think this through. We know that the range of audible frequencies is 20 Hz to 20,000 Hz. You might know that the range of an 88-note grand piano is from about 30 Hz in the bass up to around 4,000 Hz at the right-hand end of the keyboard. I can sing a range of about an octave and a half. Let's start with an octave range. You might recall that an octave jump is a doubling in frequency. Let's start with a range from the A above middle C up one octave. That A is called concert A, and it's 440 Hz. That's a value worth remembering. So our target frequency range is 440 to 880. Somehow we need to scale from the 0 to 127 that comes out of our picked slider to the range 440 to 880 to control the frequency of the cycle object. If you remember your high school maths, you might remember how to do this with linear algebra. But computers are good at maths, so let's make Macs do the work. Search for scale, and you'll find the scale object. This object takes 4 arguments that tell it how you want it to work. The first 2 numbers are for the input range, in this case 0 to 127. The second 2 numbers are for the output range, in this case from 440 to 880. Now let's connect its output to the frequency input of the cycle object. Add some comments to explain what's going on. Let's try it out. In the tutorial this week, we'll learn more about the history of the theremin, one of the world's first electronic musical instruments. In the meantime, practice making some simple sound gestures. To my ears, a slow gesture that falls in pitch is kind of sad sounding. A fast, rising pitch gesture sounds lively or happy. Have a play and see what range of gestures you can make with this simple instrument.